Alright everyone, welcome to this video. I'm Mr. Fugay. Hope you're having a great day so far. Today, we're going to talk about simplifying radicals. So to get started, some basic vocabulary and ideas we need to know for this. By definition, a radical is the inverse of an exponent. It identifies a number which multiplied by itself is going to give you the number inside of the radical. So what does that exactly mean? Well, at this first example here, it says, what is 2 squared? And then it says, what is the opposite of squaring a number? So 2 squared, as we know, is 2 times 2, which is going to give me 4. So the idea of creating a radical here is we create this. Now you probably look at that and say, wait, that's called a square root. I'll get to that comparison in just a moment. But the square root of 4, as we know, is going to be 2. That is, the number 4 is going to be the number, 2 is going to be the number which multiplied by itself is going to give us the 4. So that's the idea behind radicals and square roots. Now let's look at a couple other ideas here that we need to do before we get to some examples. So there is one property of radicals that we definitely need to know in order to do this lesson successfully, and that is the following. If we take any number and multiply it, any square root of a number and multiply it by the square root of another number, what I'm allowed to do is I'm allowed to create one single square root and multiply both of those numbers together. If a numeric example is better for you to look at, let's take a look at the square root of 2 times the square root of 7. So if I multiply those square roots together, that gives me the square root of 14. So this property that we're using here, this multiplication property, will be very important in helping us with our objective today, which is going to help us to simplify a radical. So let's look at our first example, and this one's going to be a little more straightforward. So if we look at the number square root of 50, for example, okay? That is not going to come out to be a whole number like the square root of 4 is. So the square root of 50, there is no whole number that multiplies by itself to get 50. 7 times 7 is 49, which is really, really close. But if I put the square root of 50 in my calculator, I'm going to get a decimal answer of 7.071. Okay? Now, is there a way that I can simplify this to be rewrite it a different way so that the number inside of the radical is a little smaller? Well, yes, there is. Because using that property I just talked about, the square root of 50 is actually equal to the square root of 25 times the square root of 2. Well, the square root of 25, as you may or may not know, is actually equal to the whole number 5, and the square root of 2 is still not going to simplify. That means that the square root of 50 is the same thing as 5 times square root of 2. If you put 5 square root of 2 in your calculator, you're also going to get 7.071 as your answer. Okay? So what we really need to know from this lesson is we need to identify perfect squares, because perfect squares are going to be our gateway or our key to get outside of the radical to simplify a problem like root 50. So here's a list of perfect squares that you should know. Now I'm going to be honest, if you don't know all of these, it's okay. I would definitely say, you really want to make sure you know the first 10. And I would say even somewhere around these guys too. But definitely these 1 through 10 are going to be, I think, non-negotiable in helping you be able to simplify a radical. So before we get to 4 examples, I want to look at quick 2 more definitions. All right, I've been calling inside and outside the radical, and what we have here is we actually have some vocab. The root, the number under the symbol, is called the radicand. So here in this example, the 5 and the 27, the numbers that are inside of that radical, we're going to actually call that the radicand. Okay. So still the number inside the square root, but that's the official mathematical definition. The number outside the symbol is called the index. Now what do I mean by that? Well, this 3 right here is denoting what's called a cube root. So radicals are actually all terms, not necessarily just square roots. This one on the left-hand side has no number written, but it is assumed when nothing is written that it is a 2. That is a general mathematical rule per se. So the example 1 is what we call a square root. Example 2 is what we call a cube root. And overall, together, they are considered radicals. So these are going to be our index. All right, so we'll just jot those down. Now, thankfully for today's lesson, we're really only going to focus our attention around the square root, so we won't be dealing with cube roots. So with all that being said, let's go into some examples. So example 3 here, we're going to look at 4 overall examples. And the first one, we need to simplify square roots. And the idea here is we're looking for perfect squares. So we're going to go back to our list here and think which of these perfect squares goes into the number 32. Well, I can only really pick the numbers, 1, oops, let's switch back to a pen. Sorry about that. 1, 4, 9, 16, or 25. They're the only ones that are going to go into it because of the number being so small. So 25 doesn't work. 16, however, does. So the square root of 32 is the same thing, and I'm going to draw these arrows to help distinguish this. The square root of 16 times the square root of 2. So that's super helpful because we now know the square root of 16, we've learned that that is going to be equal to 4. Square root of 2, well, that doesn't simplify. So the answer here is going to be 4 square root of 2. So the square root of 32 can be simplified to the expression 4 square root of 2. There's our first example. That's all there is to it. However, it could be sometimes a little trickier because the number is going to be much larger. Let's take something like the number 640. Okay? In the number 640, that's a really large number, and we're going to have to practice or try a lot of perfect squares. So the idea is you look at the number and say to yourself, well, is there something I can find in this number that works with one of those perfect squares? And this is where some trial and error are going to happen. But in this case, I see a 64 with a 0, so I kind of feel like let's try to divide that by 64. And by doing that, we're going to get the square root of 64, and we're going to get the square root of 10, which is great because we know the square root of 64 is a perfect square that's equal to 8. Now the question is, does the square root of 10 simplify any further? That's the question. Well, if I go ahead and break that down a little bit more, that's the same thing as square root of 5 times square root of 2. Neither of which are a perfect square, so nothing's going to work there. So we're really just going to end up with, and I'll just rewrite this cleanly down here, 8 square root of 10. Okay? So sometimes, and we'll look at another example of this in a minute, there could be other perfect squares hidden within the problem, and we'll look at that actually in our next example. In letter C, we're going to look at the square root of 196. Now, some of you might be sitting and thinking, wait a second, I think I know what's going on with this one, but hang tight. If you don't recognize this as what it is in a minute, I'm going to show you how we can still get the correct answer. So square root of 196. Let's maybe go with, in this case, the square root of 2 times the square root of 98. Remember, you can always pick any two factors that multiply to get that 196. Square root of 2, square root of 98. Okay, great. Well, 98, 2 can't break down anymore, but 98 can. 98 is going to break down to be 2 times the square root of 49. Oh, well, there we go. I like that. Square root of 49 is a perfect square. That's one I'm familiar with. And that's equal, as we know, to 7. Okay, cool. But we still have this square root of 2, and we have this square root of 2. So we have these, the bottom branches, per se, are going to be the breakdown of that 196. So 49 times 2 times 2 is going to be 196. Well, square root of 2 and square root of 2, whenever you have a pair of radicals that are the exact same number, that is always going to give us a perfect square, no matter what. So another way to identify perfect squares is going to be looking for pairs of numbers. So that's actually equal to 2, and you'll be saying to yourself, well, wait a second, there's no more radical in this. And that's correct. The answer here is 14, and that's because 196, remember, is actually going to be a perfect square here of this. So that was a shortcut, essentially, that you could look at. Now, going back to that 640 example, right? Could we have done that a little bit differently if we maybe didn't know what the perfect square was and I didn't get the 64 right off the bat? Well, the answer is yes, we could have. So, for example, if I did 640 divided by 2, okay? Oops, I lost the paper there. There we go. 2, that's going to be 320, okay? And then 320 divided by 2 is 160. And so you're seeing, okay, well, this is going to be a much more confusing way I want to state for the record. We'll say 160 is 10 times 16. And so when I look at this, we have all of these crazy things, these bottom branches. I'm going to underline them in red, okay? If we see pairs of numbers, that is another representation of a perfect square. So that's square root of 4. Square root of 10, as we know, doesn't simplify. And square root of 16 is going to be 4. So we have all of this stuff, right? Square root of 4 is 2. And so when we simplify all of this, we're going to get 8 square root of 10 still. So you can see that even if I go the more difficult route over here on the right-hand side, then I'm still going to get the same answer. So we have one last example, and then you guys are going to try a few to wrap up this video. So square root of 30. If we break down the square root of 30, we know that that can be 2 times 15. And now 2 can't break down any further, but 15 can. That's going to be 5. That's going to be 3. So we end up with 2, 5, and 3, neither of which are perfect squares. So there are two ways to look for perfect squares: to actually just see the number, or to see a pair of radicals inside of your bottom branches. So in this case, I don't see any of that. So the answer here is actually just going to be square root of 30. That's weird. What we want to take away from this example is that not all radicals will simplify. Not all radicals will simplify. So there are going to be some cases where this is going to happen, and you'll see that when you get to your practice in a moment. So I'm going to ask you this moment in this video here to take a pause, and I would like you to come down here and do these 4 quick checks. I want to take note that number 1 was square root of 32, which we already had done in the lesson. So I want you to switch that for me to square root of 40 and do that instead. Pause this video, and then in just a moment, I will reveal what the answers are. Okay, welcome back. So here are my answers, and even if the journey for you to get the answer was a little different than me, the answers that are boxed in, if they match with what you have, then you found the answer successfully. I'll take a couple quick notes on this before we end this video. In a question like number 1, 3, and 4, notice that I identified a perfect square, so I highlighted that in yellow to show you that. So I didn't find a pair of numbers, I rather found a perfect square and then just simply wrote that on the outside. But in number 2, I went a different route, right? So I did 50 times 10, and then I broke 50 down to be 5 times 10. So you can see that I found a pair of 10s, which is the same thing as the perfect square of 100. So I wrote that down below there as root 5 times root 100, and I got 10 root 5 as my answer. So all in all, what I want you to take away from this video is there are 2 ways for us to locate perfect squares. One is to actually see the perfect square in the problem, and I would highlight it or circle it, or look for a pair of numbers, and that pair of numbers will also be a perfect square. So that'll conclude this video. Feel free to go back and rewind and rewatch any portions of this video, and good luck in your practice of simplifying radicals.